One of the great scientists, Pascal, gave a law which is called Pascal's law. And this Pascal's law is very important. It is used all over the world. I want to first mention this law. What Pascal told: when a pressure is applied on the liquid kept in a closed container, then the liquid transmits that pressure to another place, and the value of pressure remains same pressure transmits to another place. This way, he told this law, this way, according to Pascal's law, pressure exerted at any point in a confined liquid transmits equally and perpendicular to all the direction. This law can be proved very easily with the help of a spherical container. Look at this, is a spherical container having 4 openings at different sides. We can name them like A, B, C and D. Let's say these are 4 openings at different places, but each of the opening has same area, equal in its area. Then if we apply force on one of them, let's say if force is applied on the piston A, each of the opening is fitted with piston, and this spherical container is filled with a liquid. Again, look at this spherical container having 4 openings at different places, and each of the opening is fitted with this is piston, and it is filled with a liquid. Now, what we are going to do? We are going to prove Pascal's law. What it says: pressure exerted at any point in a confined liquid transmits equally and perpendicular to all the direction. Let's say we are applying force on this piston A. Then the Pascal's law says that same pressure transmits to B also, same pressure transmits to C also, and the same pressure transmits to D also. According to Pascal's law, the same value of pressure will transmit to all these holes, remaining holes. But don't be confused. Actually, this spherical container appears in here in 2-dimensional diagram, but we have to imagine about ball-like structure. In a ball-like structure, in my side there is an opening which is fitted with the piston, and in opposite side there is another opening fitted with piston, and left hand side and right hand side also fitted with piston. This is somewhat spherical, but it appears a little different in this 2-dimensional figure. When a force is applied on A, this piston A, then the pressure is exerted on the liquid. Then, according to Pascal's law, same pressure transmits to B also, C also, D also. How can we prove this? The same pressure transmits to B, C and D also according to Pascal's law. It can be noticed very easily by this way. Because of this pressure, piston B will be pushed away. C will also be pushed away from its original position, and D will also be pushed away. All the pistons moves from its original position, and if we measure the distance moved by piston B, C and D, then what is found? All of them are moved to same distance. If B is moving up to 2 cm distance from its original position, then C is also found to be moved with the same distance 2 cm, and D is also found to be moved with the same distance 2 cm. What it means? It means if they are displaced by same distance, it means they are receiving same pressure. That's why pressure exerted at any point in a confined liquid transmits equally and perpendicular to all the direction. Perpendicular means this pressure transmit this way, it acts in this direction, perpendicular to that surface which receives the pressure.